Hi, I'm John Paulraj, and in this particular video, we will solve question number 2 from paper 3, time zone 3, May 2025, IB Mathematics Applications and Interpretations. Let's start. So this is question number 2, and it says that George is researching the growth in the number of electric vehicles in the European Union in order to investigate some of the difficulties that might arise if the target of banning sales of all petrol and diesel cars in 2035 is to be met. Okay, George begins his research by predicting how many electric vehicles will be in the European Union in 2035. So that's what he wants to do, a prediction. The number of electric vehicles in the European Union, N, measured in millions, is shown in the following table. Time t is measured in years from the beginning of 2016. T is a real number. T is a real number. Okay, I wonder why they've kept t as a real number but not a natural number. We'll find out later. That's an interesting thing, right? Because measured in years. Now when you're talking about years beginning of 2000, I don't know. We'll find out why it's a good question to think about, right? Okay, let's keep going. So that's the table. 2016, beginning of 2016, 2017, 18, 19, and that's t is 1, 2, 3, 4, 5, 6, 7. Okay, that's all right. N is 0.2. This is the number of electric vehicles, but remember it's in millions, right? Somebody said that it's measured in millions. So that means this 0.2 literally means 0.2 millions, okay? And a million is 10 to the power of 6. Let's just keep that in mind, okay? So 0.2 times 10 to the power of 6, 0.3 times 10 to the power of 6. That's how you have to interpret the third row, okay? George models his data using the logistic function that's given to us, 310 divided by 1 plus capital C e to the power of a minus kt. C and K are positive real numbers. So part A, in context, explain the significance of 310 in George's logistic function. This one, the numerator. If you recall from logistic function, the term on the numerator, that constant is actually the end behavior, the horizontal asymptote, okay? What happens towards the end, it is also sometimes referred to as the carrying capacity. I'll just put that word down, carrying capacity. But that is the theory. What we actually want is in the context. We want to explain the context of significance. So in the context of the question 310, that number is actually 310 million. Okay, so that's the maximum number. It's like the upper limit, right? End behavior, maximum number of electric vehicles, EVs. Okay, so we're going to write that thing down quickly. Where shall I write? Maybe right under this. Maybe start from here. So this is question 2A. In George's logistic function 310 represents 310 million maximum number. Maybe we should reword it like this. Represents the maximum number of electric vehicles is 310 million. Okay, in George's logistic function, the term 310 represents the maximum number of electric vehicles is 310 million. I think that is clear, all right? So that's 2A. Then what about 2B? 2B says use the value of n is equal, use the value of n at t equals 1 to show that C is equal to 1549 e to the power of k. T equals 1, this one, use the value of n, this is the n, and to show that, so in this equation, all right, in this equation, n is equal to 0.2. So let me just copy this equation down correctly first. So this is 2b, capital N is, what was that equation? 310 over 1 plus c e to the power of minus kt, 1 plus c e to the power of a minus kt. And they're saying t equals 1, I think capital N was 0.1 or 0.2? 0.2, okay? 0.2. So let's do that. So this is 0.2 equals 310, 1 plus c times e to the power of and the t is 1, so it's just a minus k. All right, so we just rearrange that because I think what they said is we want to show that c is equal to. So a little bit of algebraic adjustment, okay? That's what needs to be done here. So this becomes 0.2, 1 plus c e to the power of minus k equals 310, and so that's just 0.2 plus 0.2 c e to the power of a minus k is 310, and then we can say 0.2 c e to the power of minus k must be equal to 310 minus 0.2, and we can divide by 0.2, so c times e to the power of minus k is equal to 310 minus 0.2, this whole thing divided by 0.2, and then we can divide it further by e to the power of a minus k, which will then become give us this term 310 minus 0.2, the whole thing is divided by 0.2 times e to the power of k. Remember that. Okay, so that's the expression. I think we got it. We just have to put it in the calculator and see that that value is equal to 1549. All right, let's just check that, whether that value is equal to 1549. So let's just jump to the calculator now, and I will just first make sure that the calculator is back to the window. Sometimes this happens. Okay, all right, so I'm just going to enter a new page first, new problem, okay, because this is question number 2. So into new problem, calculator, and I'm just going to evaluate this expression as I want it. I need a template for this, so 310 minus 0.2 and then divided by 0.2, and when I hit enter I get 155E3, and we've already seen this thing before. Let me just see what that value is. Okay, so this is 1549. There you go, 1549. We just want, that's a rounded off value, by the way. Okay, this is rounded off because it's rounded to 3SF, so you can see that is 1550. Okay, but we want the 1549 as it is, so we can bring that thing down and say therefore, and we can write down using GDC. Don't forget to mention that c is equal to 1549 e to the power of minus e to the power of k, just as we need it. Okay, so this was 2b. Was it 2b? Yeah, part 1. 2b part 1. Make sure we label that 2b, and that was part 1. All right, what's the next one? Use the value of n. Use the value of n at t equals 7 to find an expression for c. Okay, so we already got c is equal to this one, okay, at t equals 1, and now we are using the value t at 7, this one, right, 3.1 at t equals 7. Okay, we want to find an expression for c. Let's do that. So this is b part 1. Let me just draw a line so that, you know, we can have the two part b's adjacent to each other. Okay, so this is b part 2, and at t equals 7, c n, sorry, capital N is, what is it, 2.1, 3.1, 3.1, and so c, which is given by this formula, capital N is 310, 1 plus c e to the power of t is 7, right? So we'll write it as minus 7k. Okay, you can see that that's a substitution. So t equals 7, and k is there as an unknown. C, we have the value of c here, right? C is a value here. So we want an expression for c, I think they said, and I think we are probably going to equate the two. Find a second expression. Can you say that? Find a second expression, and maybe, yeah, towards the next part we'll find the value of c. Okay, to find the value. All right, I see where it's going. So a second expression for c, similar kind of algebra. So n is 3.1, so perhaps even that can be substituted. So we can write that thing here as 3.1. Okay, and then that is in the same way 3.1, 1 plus c e to the power of minus 7k equals to 310, and let's do that. 3.1 plus 3.1c e to the power of minus 7k is equal to 310. In the same way, we will do that. You'll get c is equal to 310 minus 3.1 divided by 3.1, and here we can have e to the power of a 7k. All right, similar, just like this. All right, so again we can say using GDC. All right, let's just evaluate the term in the bracket. Jumping over to the calculator, Okay, and since it's very similar, let's just bring that template down, and it's 310 minus 3.1, and here also we can type that 3.1, and if I hit enter, it's 99. Can I bring it down and see what it is? Just perfectly 99. Okay, so we can come back and say the C is nothing but 99 e to the power of 7k. So we got two expressions. We got these two expressions. We got C is equal to 1549 e to the power of k for n t is equal to 1, and for t equals 7 we got C is equal to 99 e to the power of 7k. Now that we have, I think the question next part is to find k and c, right? Part C. Use your answers to part B to find the value for k and c. All right, so that's C part 1 and 2. Let's under that. This is to C part 1 is okay. So we've got the two expressions. Let's just write them down. C equals 1549 e to the power of k, and C equals 99 e to the power of 7k. All right, so they both are equal. We can just equate them, and we can say that therefore 99 e to the power of 7k must be equal to 1549 e to the power of k. Nice algebraic process. Okay, so e to the power of 7k divided by e to the power of k is nothing but 1549 divided by 99. Right, so this just gives us e to the power of 7k minus k. If you want to understand, that's basically exponents. Okay, and this is I can use the calculator here. 1549 divided by 99, right? So let's just get that thing down. So 1549 99, will it be decimal or 15.6? Let me just see if it's rounded to 15.6. I always just check that, whether the rounding of is okay. So I have 15.6. Let's just bring that thing down. 15.6. So this is e to the power of 6k is 15.6. Now we want to solve for k, remember? So remember your logs at this point of time. 6k must be equal to ln of 15.6, all right? Or in other words, k is nothing but 1/6 times ln of 15.6, all right? So having said that, let's jump over and let's bring ln. Okay, and so this is, in fact, we can write it as we want, right? 1/6, and there we can write multiplied by ln of, what was that, 15.6. Let's bring the whole term down, shall we? This one, just to get more accuracy, okay? And hit Control Enter. 0.458. Let's just check that 0.458 is correct. Okay, so that k value, the k that we found out is 0.458 up to 3SF. Okay, sometimes it's good to even mention that 3SF. So this is what I've written here. K is 0.458. I think that is the first thing we need to find out. The next one is to find out C. Having found out K, we can use that value because that's just 1 point. Oh, that was 2 points. I think it's less now for the work that, yeah. Okay, this is C, this is C. Okay, meaning C part 1. Now C part 2 is to find the value of C. So you can put it back into any one of them, So you can, let's put here, okay, so substituting in B part 1, the answer to B part 1, what do we have? We have C equals 1549 e to the power of the k that we just found out was 0.458, and then we can say, I think even here we have to say using GDC, by the way, using GDC. Everywhere you use a calculator, make sure that you mention that, all right? So here also I'll say using GDC. Okay, let's just jump over. We have 154. Is it 1549 or 1547? It's 1549. Can you see this error? You should see this, okay? I was reading and I wrote something else. Can you see that? And I was about to enter that. Okay, now this is a very common thing which can happen in exams. Okay, for those of you who watched this before, You might have seen how many times I do that, and the reason I keep it open without editing it so that you know that even as a grown-up, no matter how many times I've done this, it's just a common thing. When you're writing something, sometimes just copying something, just look at that. Okay, that can happen. It's a very real thing. This is what counts for what is called, what we say, silly mistakes. Okay, this is what counts for that. How to overcome these silly mistakes? Yeah, I have to still learn how to overcome these silly mistakes, but I can give you some tips. And my tips are not just about overcoming. My tips probably would be about how to check if you see me going back and forth, just to know, am I copying it correctly? Am I, maybe that's a better habit to have. I don't know whether we can overcome what is so-called silly mistakes, because even when you're copying something down, that error is going to be there. But maybe a good habit is always checking again. Did I copy it down? Did I copy down the values? If you look at my videos, sometimes you see me going back and forth, even if I've, input the values correctly. I do that just because of this one thing called the human error, okay, which we then term it as silly mistakes. Okay, sorry for the diversion, but we are going to jump to the calculator quickly and see this played out. So it's 1549 times e to the power of this one, and we'll bring that term. Okay, I want to bring that entire term. I'm just going to copy that and paste it here so that it will give me all the digits. Okay, can you see that? It will give me all the digits, and now I'll have a better accuracy. So it's 245 e to the power of 3. So basically, you want to know what the term is, it'll just give you 2449.7. So it's basically 2450. Okay, up to 3SF, 2450. We're going to round it off and we can write it like that. So you can write it as 24503 SF. Okay, you see what I've written down? Okay, 2450 up to 3SF. That's the value of C and that's the value of K. All right, so we have completed A, B, and C. What are we doing with time? I think we will stop here. Okay, that's all the time that we have for this particular video. If you found this video useful, please make sure that you like this video, share this video with a friend, and subscribe to my channel. If you visit my channel, you'll see plenty other videos on my channel. Do check them out. And if you want any question, any topic, any concept clarified or answered, do mention that in the comments and I will make a video for you.